Um, let's just take a quick look. I actually have to run in like 10 minutes to go pick up Damon, so maybe we'll just cut this short. See, there's an RGW one. That sounds fine. That's from Doug doing DFG stuff. Let's see, boost for fragmentation calculation. I think Adam is going to take a look at that, or you were supposed to take a look at that. That too. Aging tests. Looks like there's progress on the persistent read-only RBD cache. Jason needs to look at. G-tests speedups are merged. LibRDD speedups are merged. Async recovery stuff going on. Who is Aaron? He's been going off on this other pull request. I forget.
Yeah, I don't know.
He's like, he's helping track down this like super obscure peering bug. I'm just curious what it works for. Okay.
He seems really, really concerned about the async recovery stuff.
Yeah. I think I've looked at this particular pull request yet. And then the huge page thing that Radic is working on. That I think is getting close. What was the last thing on the huge pages, Radic? Was that trying to figure out what page size to use? Was that the last step? Okay.
And still, it looks the only reasonable way is to employ SysFS. That's fine. Sorry, cannot hear you.
Oh, sorry. Do you have to look in SysFS, meminfo, or whatever to parse it out and find out what the size is?
Yeah, and finally, still, I guess operator will need to decide which huge page size we should use. Or we can just try to the smallest one possible. That's
yeah, it seems like maybe we hard code or set options for like the min, the max size, and then we look at the available sizes and pick one that's between those. And if not, then we don't use them. Like we set min at 512K and max at like.
I'm not sure. I'm not sure whether it's reasonable to spend. I'm not sure whether it's reasonable to try to automate or make this easier for operator, because using explicit huge pages actually requires intervention from system administrator. He needs to set appropriate parameter in controls.
On boot up.
Yep, on boot up or on runtime via syscontrol. Yep.
I didn't realize that.
Yes, we have a fallback.
Can you choose the size when you do that?
No, I'm not aware about that control. It seems to me that just you tells the kernel how big pool of huge pages you are going to reserve.
Yeah. Okay.
But we have a fallback to transparent huge pages that doesn't need any effort from operator, but are less efficient.
You might probably think about.
Well, maybe we should just merge it as is then with the config option, and if somebody comes up with a better way to automate it or something. Because I mean, maybe you would imagine that the systemd unit file sets up the pool or something, or I don't know, whatever. But it's weird because you have to have root in order to set the huge page pools. So.
Fortunately, yeah. The default huge page size looks reasonable for current processors. Basically, I guess it's quite rare to get something different than that to max. Maybe if someone is running old system with PSE 36 instead of physical address extension or AMD 64.
All right. It's a 1 megabyte.
2 megs, 2
2
megs
megs.
for
Okay.
AMD64 and 2 megs for physical address extension, if I recall
Okay.
correctly.
So let's just set it at 2 megs as the default then and be done with it. That sound good?
Okay.
Okay. Um, all right, I guess that's it for all this MDS stuff. IO throttler, Eric's working on. Op tracker optimizations are coming up next after huge pages. I think you have some initial results that just
And
change the application part.
also
Sounds
there is
good.
a throttle change I sent just for early review. Got your comments.
That's what it was. That's what I was trying to remember. It was the throttle that led you to the perf counters. Okay.
Yeah, basically I'm just looking on the intersection between Messenger and TP-OSD-TP, and there are lots of small gizmos like throttle, like perf counters that are especially painful, especially that are painful for throttle because we are updating 5 or 6 perf counters during get or fail of throttle.
Okay. Yeah, my only concern with that throttle one is just making sure that we don't introduce a new weight race condition where you end up with somebody who's waiting even though the throttle got dropped down. So we need to make sure there's no race between somebody trying to get throttle and somebody putting throttle and somebody getting stuck. But I had one theory about where there might be an issue, but I wasn't sure about. I don't know if you fixed it or not, or if I was wrong.
Not yet.
But okay. Anyway, that's my only concern. So if you want to re-review it, or maybe Adam can review it, or convince ourselves basically that's safe, then I think it's
Sure.
good.
In worst case, it still can be useful because the commit that could be racy applies only to the put. It doesn't affect get or fail. That stays on the interconnection between the messenger and TP-OSD-TP. So even if you would need to strip this one commit, this wouldn't be end of world, I guess.
Yep. Okay. Okay. Sounds good. I think that's it for the pull requests. We got a bunch of topics here. I gotta run out for 10 minutes. I'll be back in about 10 minutes. Maybe you guys can start talking about the GLX stuff.
Sure.
Right. Be right back.
All right. Let's see. I gotta find my window again for this. There we go. All right. I don't know. Are people interested in talking about the PG log stuff or the memory target, OC memory targets first, or something else?
Do memory targets.
Memory target. All right. I was afraid you were going to say that because I was still actually making graphs for it.
Okay. Go into the PG log first then.
Sure, as long as I don't have to say a whole lot, I guess. But maybe I'll say something quick. So Lisa did all the work on this, and it appears to more or less do what she says, which is good. But it won't work in its current form.
It's a prototype.
Yeah, exactly. But it's interesting because it's a really interesting behavior trade-off from what I'm seeing. Her runs that she did are faster on Optane and actually faster on the NVMe drive, the P3700 that she has. Her numbers on the P3700 are way higher than mine, though. I don't understand why she's getting like 2x higher performance than I am. But in any event, She's seeing better performance with her PR. I'm seeing ever so slightly better performance with hers than master. But I'm seeing a really big behavior change, and it's exactly what you'd expect. The amount of key value pairs coming in to compaction from the write-ahead log in RocksDB has reduced way down, and the number of output records has also decreased dramatically. The amount of time that is spent dealing with that stuff in RocksDB has decreased. So all of that's good. But unfortunately, because these are small, the PG log entries are small for this RBD workload. One, it's there's no coalescing of anything, so we're just like packing this stuff into 4K chunks, even though they're like 1K in size. And then also there's tons of 4K random IO happening to all these different logs on disk, rather than kind of appending these things in the transaction in the write-ahead log in RocksDB. So at least in my test, it ends up looking like it's kind of a wash between doing it in RocksDB versus doing this in these random IOs all over the place.
Well, the one thing that I noticed in your tests that looked pretty interesting was the tail latency seems much lower with Lisa's prototype.
Yeah, and it makes sense, right?
Yeah.
The time you spend in compaction is way less. So if you make the assumption that your tail latency is often affected by RocksDB doing a bunch of background work, you'd expect that the impact of that might be a lot less. It might be more consistent if you're just doing like constant random IO in the background on one of these things. Unless their compaction, I guess, unless the SSD compaction itself is bad, but presumably Intel's much better at that on their hardware than random user space processes.
Right. I guess the other thing I'd be more curious about is how this works for like an RGW style workload for like a bucket index where it's doing all OMAP operations. Is the coalescing like actually improving performance there, or is it going to be a wash again?
Yeah, I was wondering about that too. So that'll be interesting to look at and see what happens. The only thing is that it might not work, right? Because the entries might be too long.
Yeah, right. For the prototype, you may have to increase the block size or something.
Yeah. The other thing I'm wondering though, this leads me back to the question of, okay, it looks to me just based on this, like getting all of this stuff out of RocksDB's database is beneficial. But we're paying a big penalty for having it, at least on this kind of hardware, we're paying a big penalty for having these tiny little PG log writes that aren't even 4K. Maybe it'd be better if it was like a 512K sector size and we were actually like, using multiple sectors.
Yeah, you still got the erase block size though for the SSDs.
How big is that?
Like more on the order of 128K.
Okay.
So nowhere near where we're gonna be patching up enough to do that size of a write every time.
Any idea what it's like on Optane?
No clue.
Okay. Well, so I guess the question I have then is, would something like this alternate scheme where you have a single log, current active log, but then you kind of mark it immutable at some point, and you compact, or I guess in this case, if it was not RocksDB's other data, if it was just this stuff, then you just mark it immutable, and then once all the references have gone away to it, then you can delete it, and you eat the space amp, but never rewrite, never compact. I wonder how something like that would do.
Yeah, I worry about introducing other kinds of like asynchronous background work like that, because you always end up running into some threshold where you have to clean up at least as fast as you're writing. If you're not doing that constantly with that constant overhead, which is kind of similar to doing it online and not doing the cleanup, you're going to have more variable latency later. some
So,
periods of higher background work.
that's essentially what we're doing, only worse with compaction in RocksDB, right?
Exactly. Yeah.
This the delete plus the compaction workload versus just the eventual delete.
Right.
Yeah,
So,
I don't know.
I mean, just from a latency perspective, I think it might be worth doing this, even if it's a wash in terms of overall throughput for all these workloads. The other case where it might help would be RBD on hard disks. That's a lot more random I/O that we're coalescing a little bit by at least writing the info and the PG log entry in one chunk.
So RBD and hard disks, how would this? This would only work if you could do the PG log on the if you had like a flash drive for the log, right? Otherwise this is terrible, right?
Yeah, not necessarily, I guess. And you're doing a couple of RocksDB and writes each RBD write, right? Because you're storing the PG info and the PG log entry. Maybe those might end up getting coalesced by RocksDB into one write on disk. But it certainly seems like you're going to get more locality if you're writing these sequentially in a ring buffer style like this.
But every single write potentially is in a different PG, right? So if you're going to be basically creating like random I/O instead of coalescing it into the transaction in the wall.
Right. Yeah, I guess in the Blue Store case, if we actually have an SSD journal and wall and database, it's probably going to be it's probably not going to help. But if it's a pure HDD case, it might not be worse.
I don't know. I think the pure HDD case is the one that I'd be worried about, but we'll see, maybe.
Yeah, I think it's worth trying at least.
So to me it seems like the area where the place where this could potentially really be good, right? It'd be like if you've got a small amount of like ridiculously fast persistent storage, NVDIMMs or Optane or whatever it is, especially if it's like reasonable to do like cache size writes to it.
Right.
Then this the waste shouldn't be too bad if it's like 128 bytes or whatever, and then presumably the random nature of all of this shouldn't be a problem. So I wonder if that's kind of where this really could be beneficial, is essentially making pglog for all intents and purposes kind of like go away as a workload on the block device.
How would it go?
Yeah, possibly. He was talking about like using putting it off to the side in like an persistent memory or Optane device that's even faster than your main storage device.
Oh yeah, that'd be great.
Yeah, to me it seems like the real like area where Lisa stuff would really be useful would be if you have like some kind of byte addressable or even like cache line size, right?
Yeah.
Small storage thing that you can just like
this would be a perfect
randomly
place
write
to
this
use
stuff to.
the NVML library, the pmem.io stuff or whatever.
Yeah. Right now, like her stuff it's like hard coded 4K like block size, which is not real optimal for this, and breaks if it's too big.
Yeah.
But,
well, I mean, even if it turned into 8K, I don't think it would matter that much. Like if a random large objects that they couldn't fit in 4K, it would be 8K. Why does it matter? I think the issue is that it's the code complexity, and I think we need to have both because our hard disks, we still want to put it in RocksDB because of the extra I/O. and then is it worth it? And 10%
Yeah, so
doesn't feel like it's worth it to me.
also,
But,
yeah, the 10% isn't that great, but I think what's interesting is the tail latency. Like RocksDB has, because of the compaction, has much higher tail latency, and in Mark's run at least, it was like something like what was it, like 25 versus 9.
yeah.
Yeah, like 25,000 versus 9,000 microseconds. Is that right?
Yeah.
And
I
but the
guess,
a couple other cases we're kind of interested in here. One is the like RGW bucket next workload, which is totally different from RBD, and just getting less I/O to RocksDB for that workload may help.
Sage, the other thing I'm wondering about here too is, okay, so I mean, right now it's really kind of suboptimal, right? You're shoving like 1K of data into a 4K write, whereas on something like maybe on Optane, maybe you can really do like byte addressable small writes faster. I don't know. I'm just asserting that, but maybe you can. Maybe you don't need to actually do like a padded 4K write.
yeah. Well, on the DIMM form factor, yes. On the SSD form factor, not. You can't.
Okay, I'm not up to how different those two are, I guess, but yeah, like on the DIMM form factor, I mean that's kind of where it's more interesting, right?
Yeah. Yeah.
The other thing I was wondering too is whether or not you might see a better situation if you did something where you were still coalescing the writes into one log, maybe with or maybe without the other RocksDB data, but then just marking those logs, old logs, as being immutable until all references to them have gone away, and then not compacting anything that you've marked as being short-lived. So the idea is
Talking about
you still
still in the wall, and you modify RocksDB so it just doesn't get rid of those write buffers.
either RocksDB or you have a custom blue store or whatever store write ahead log that is smart about what gets moved on and what gets left. I mean, it's space amplification. You potentially bad space amplification if you end up like in a pathological case where you end up with like one entry per log that's sticking around or something ridiculous. But in practice, I don't think it would ever be that bad.
Yeah.
And if it really did in practice, you could compact. Like you could say, every hour compact all this ridiculous stuff that's sitting around. But
yeah.
You almost want a different compaction schedule for different classes of data coming in.
Which almost means like you want to write your own wall and then feed what falls out of it into RocksDB sort of in a little bit more controlled way. Mm-hmm. Yep, that sounds like a possible path and a lot of work, but a possible path. Yeah. Yeah, I'm trying to think if any of this is going to matter with CStore. Everything's getting streamed into these segments. Segments are generally long-lived, so the data from the wall stuff is going to be long dead by the time we go and scavenge it. I mean, seems like we wouldn't have this problem there. We're just going to mix those pglog entries along with all the other random metadata that we're doing.
In that one, have Is that like in the works now, or is that still kind of the new store, whatever it's gonna be, C store? Yeah.
Name is sticking so far. I wrote up a description and it's in the docs, in the dev docs right now. I'm trying to find some academics in the project, work on it. We don't have time right now, but and I'd be happy for anybody to start working on it. We'll see. Yeah. I think the sooner that happens, the better.
Yeah. I guess the question in my mind then would be with Blue Store, kind of how long do we want it to be kind of around for, and how much work do we want to put into it?
It feels to me like it's going to be probably 2 years before we have, probably at the earliest, before we have something else for Flash. So Blue Store needs to last that long. I'm a little hesitant to make like super crazy changes to it though. Implementing our own wall to interact better with the PGLock stuff like feels like it doesn't meet the threshold.
I think it really depends on how much the tail latency effect is very strong. I think we want to see also how this kind of change affects the RGW style workload.
Yeah.
If it decreases latency there dramatically, or even just tail latency, I think that's pretty valuable.
Yeah.
I wonder if we could convince anyone on the RocksDB team that like different compaction schedules for different prefix data is like a worthy or useful addition to RocksDB.
Isn't that why they built column families?
It doesn't affect the write-ahead log though. That's only inside the database.
Yeah. I mean, I think this is the thing that would.
Sorry, Sage. Go ahead.
I was gonna say this feels like the thing that is general enough to go into RocksDB that it could be valuable to other loads or whatever, where we avoid writing things to level 0 for some column families and let the wall just get really big because we know it's usually gonna get pruned. But it might be hard to implement.
That's my concern. Is I think it requires a lot of extra tracking that they don't have. I mean, I haven't looked at the RocksDB code ever, but the idea of making things live only in the log is kind of antithetical to the general LSM data structure.
Yeah.
So it would not surprise me if it wasn't prepared for that at all.
Yeah.
Although we could talk to them.
Yeah, I mean, it might be something.
Someone already talks to them. Is it Keith who has been talking to them, or someone, or is it
I think
you,
Lisa.
Mark?
I think it was Lisa. I don't remember. I don't know. It might be as simple as like, if the PG logs are in a different column family, instead of writing out the L0 thing file, you just like don't write it. And keep the logs around because it's small. And then you try again the next time. And if it's, yeah, I don't know. Yeah, it seems like you could do something, but it's going to burn CPU in the process. So
yeah, no, you'd have to like compact the extra column family into new level zeros or something, or into the new level 0 logging, because they can't just leave dangling logs level 0 references.
Yeah.
Well, could it be something as simple though as for certain classes of data you avoid you have them flags, you avoid compacting them in the first round, but then you keep those files around and you compact them in a second round that maybe is much longer lasting, right? So you for like default data, default data, you compact it once you've hit however many log files have filled up in their current settings that they have for saying, you start compacting after 2 logs or 3 logs or whatever filled up. And then for this other class, you start compacting after 10 logs have filled up.
How is that simpler? You know, have, more logs sitting around you need to track which state they're in and reread them, and
you've accumulated more tombstones, right?
okay,
so now
so it might be more efficient on some metrics, but that's not the same as simpler.
No, it's not simpler. I'm not claiming it's simpler. It's more complicated, right?
You said as simple as. That means
sorry, as simple as relative to doing like a reference count scheme, right? That's more complicated.
Just brainstorming, basically.
Yeah.
Yeah, I don't know. I feel like it's probably not a good use of our time unless and until we have somebody who is actually a RxDB developer to like bounce ideas off of.
Yeah, I agree.
All right, should we talk about the memory targets?
I almost had my second graph done, but I don't quite. So let me just share what I've got. Is that visible? Is it readable?
Visible.
Readable enough.
I can make it. Does that look better?
Yeah.
Mm-hmm.
All right. So the gist of this is that when you set BlueStore's cache size to something, and let's say 3 gigabytes, you don't get really consistent memory usage for the OSD as reported by TOP or PS, anything that measures RSS memory. In some of the tests I've done, like an RBD workload, you might end up with like roughly 4.5 to 5 gigabytes of RSS memory usage. With an RGW workload that does like small object writes, you might end up with something closer to like 7.5. I spent some time looking into mAdvise and tcmalloc and what it's doing. And when you release memory, all it's really doing is marking mAdvise don't need. So you end up with a bunch of memory that's unmapped, but there's no, as far as I can tell, and I do not claim this is right. I still am very, very confused as to what the kernel actually does, but it appears to me that the kernel may or may not reclaim those pages. And it may actually do it opportunistically when there's memory pressure, but otherwise just kind of leave them alone and let them sit around. Again, I don't know that that's totally right. It definitely seems like it varies by platform. OS X may do something different than Linux. Linux, it theoretically, I thought they were supposed to be reclaimed right away, but I don't know that's necessarily true. So anyway, the goal of this is to try to control the memory usage of the OSD by tuning the cache size in BlueStore based on some target. So in this case, there's an option that's been added for I think in the branch I have right now, it's called like OSD memory soft cap or something like that, but maybe target's a better name, I don't know. And we try to then tune the cache size so that the overall memory usage of the OSD is around that. Memory usage in this case I've defined as the amount of mapped memory. So that is basically the heap size of the process minus the unmapped memory, which is what you get once you do tcmalloc's like release memory whatever call. So the branch appears to more or less be working. This is an RBD workload. the RGW numbers in the other tab aren't quite done yet. I didn't finish pasting them in, but you can see basically at first, before any work is really being done, or when it's just kind of doing this pre-fill or whatever, we aren't using very much memory yet. So this auto-tuning thing will set the, we started out actually at the very, very beginning using the default flash cache size for BlueStore, which is around 3 gigs. But very quickly, since the mapped memory usage is low, we push that all the way up to the OSD target size. So potentially, in a theoretical world, you could have the entire amount of memory be devoted to, or the entire mapped memory going to the BlueStore cache, which isn't real, but until we start using lots of memory, that's what it's setting it to, is kind of an upper bound. Once we start doing writes, like real writes, this is like a pre-fill stage where they're 4 megabyte writes. In this case, the data caching in BlueStore is enabled, and so very quickly we push the amount of mapped memory up and the heap size up, and you can see that kind of in the probably around, I don't know, 100 seconds in or whatever. Now we're starting to reduce the cache size because we're trying to keep that mapped memory usage really close to the target size. And right around maybe the 900 second mark there, that's when 4K random writes start. And there now all of a sudden the heap size has jumped way up. We're using more memory for stuff, probably PG log, I would assume. And other things, potentially more fragmentation too. So now the cache size drops way down, under 3 gigs in this case, and we're kind of bouncing around that mapped memory target. The RSS
what mapped is. Mapped is the heap size minus unmapped pages.
Yes, that's what I'm calling it, but that's what it is the heap size minus unmapped pages.
Okay.
If there's a better term for that, I'm happy to use it. That's just what I came up with in 2 seconds when I named it. And the actual RSS memory usage is like kind of variable between the amount of mapped memory and the heap size. So that's to me indicating that the kernel is like opportunistically reclaiming these things, but not guaranteed to do so.
Mm-hmm. Yeah. It looks like about 10%.
Yeah, and I don't know if that's consistently 10% or if it will change depending on like how much memory is assigned and used and everything.
It'll be interesting to see how that changes when with RGW, if this looks any different. I have one question. The RSS memory is 0 until 900 seconds. Is that just a data collection thing?
Yeah, that's when the test actually started at the 900 second mark, so nothing was recorded before that.
Got it. Okay. Cool. This looks awesome. I think this is the way to go. I think my main concern is how we do the dance around the config options. Like what happens if you set both the BlueStore cache size and the OSD memory target? Which one takes precedence over the other? That's the main thing. I guess we just choose. Probably the new one takes precedence over the old one. That makes it easier. And so if you set OSD target memory, then the BlueStore cache size is just ignored completely. That's probably an easy way to do it.
Yeah. I think too, long term, I'd be in favor of making stuff like that, the BlueStore cache size, a dev option instead of like a user focused option, so that yes, you can like manually. Yeah.
Yep.
Yeah, really, it'd be nice if really the user was just saying, okay, here's how much memory I want to target for the OSD, and just go and tune yourself. I don't want to think about ratios. I don't want to think about what cache BlueStore has. I mean, maybe I want to know. Maybe I want reporting on it so that I know if I need more, if I want more memory or whatever. But
Yeah, and it'd be nice to know that 10% of it's being used for BlueStore and 90% is PG logs. That might be useful information to understand other things, but we can report all that stuff out. So I guess there are just a couple things that come to mind here. One is that right now at the beginning it's jumping the BlueStore cache all the way up to the target. We could probably build in like a baseline that's a little bit more conservative, because probably that's not the case. We know that we're going to use either on the order of 500 megs or on the order of 10% or something for other stuff. And so maybe until the BlueStore cache is actually full, we don't bother. We don't actually increase it all the way up.
Yeah.
So we stay at sort of a conservative starting point. Otherwise, we're guaranteed to overshoot and then adjust down, or it'd be better to sort of ease up to the limit.
Yeah. I was thinking a little bit about ways to do that too, like in terms of easing up to it. It might even be something like, I don't know. Yeah, this is
tricky.
nice because it's really, really straightforward, right? It's just like, okay, boom, set it here. Now we'll walk it down.
Yeah.
But yeah, you're right. I mean, it can overshoot a little bit. But interestingly, though, at the beginning there, it doesn't overshoot as badly as it does during normal operation.
Yeah.
Like during normal operation, once you get into it, it's like you've got RocksDB. When it compacts, it uses way more memory than it normally does, unless you set like the hard cap, which then can block writes.
Mm-hmm.
So RocksDB can when it's compacting, read tons of stuff into the block cache and overshoot the block cache target. So this is sort of trying to like compensate for that. That's probably why there's one of the reasons why there's all this variability in it.
Mm-hmm.
So I don't think we're ever going to get away from overshooting unless we under target.
Yeah. I guess that's the question. Should we like build in this like 10% factor, where if you say the target is 4.5 gigs, then you would get this graph, basically. Or maybe if you set the target as 5 gigs, then you would get this graph that the target is 4.
Yeah. I think it's a question of whether or not we, implicitly do that or explicitly tell the user, this is the target, but you need to over provision by 20% when you do it.
I think the other way is probably more user friendly, where the user actually sees the RSS match what their setting is.
Yeah. Yep.
But I guess the other question is how consistent this is with like RGW workloads or workloads that are more visible.
Oh, yeah. So yeah, definitely we want to see this for RGW and a couple other things. I have one question though. Could we just change this so that instead of using mapped as your target, you actually use RSS?
No, it breaks, because what happens if you target RSS is the RSS usage doesn't go down, it remains like flat, but you keep decreasing the cache in an attempt to compensate for it, and then you end up with like no cache and a huge amount of like unmapped pages, and it's super irritating. That's why I tried it first, and it didn't work.
What if you took like a 10-minute average of the target versus the RSS to adjust what your factor is? And so you would do this maybe like 5 times over the course of this whole time span. You like slightly adjust what your ratio of your mapped target or your target to your actual RSS, because the RSS is eventually tracking somewhat, right?
Well, the problem seems to be that it seems to be dependent on memory pressure. If the current that's the feeling I'm getting right now, is that if there's no memory pressure, the kernel is just like whatever, and you might end up with like a ton of RSS memory usage. Whereas if it's under memory pressure, like this number might actually be way, way closer if my machine was like trying to swap.
Okay. So we could just hard code we probably just need to do some experiments and get some like real world intuition for like what that variability is, and then just have an option that sets that somewhere.
It's to me, it looks like the variability is the high watermark in low cache pressure scenarios, and it's probably going to be pretty close to the mapped memory in high memory pressure scenarios.
Mm-hmm.
So maybe we can figure out how to like reproduce a high memory pressure scenario on those boxes, like run a compile or something, I don't know, in the background, just to like see how tight that RSS gets.
This was on this was on my my dev box, so I can do that pretty easily since I don't have a ridiculous amount of memory. I think the harder part though is we don't know what the high memory watermark is going to be. Like if RocksDB ends up like way overshooting its cache size, the high watermark could be maybe 6 gigs or something. And if there's not memory pressure, then the RSS value might not be a good thing to be incorporating in.
Yeah, exactly. Yeah, I think you're right. I think we probably can't. Probably what we have to do is say that this will approximate your RSS memory usage under memory pressure with a big asterisk, and have like a FAQ type thing that why is my RSS higher than my target memory? Well, because there's no memory pressure on your system. And if you do something like X, you have memory pressure, then the kernel should reclaim it and it'll converge towards what the target is.
And this is not just a problem we have. Like Firefox and Chrome and all these other projects have like bug reports about the exact same thing where users are complaining the RSS memory usage is high, and they're like, no, really it's not as big of a deal as it looks like it is, blah, 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 blah.
Kernel's just not reclaiming memory, right? Yeah.
Yeah, and intentionally so, right? Because when it reclaims memory, then it costs more to get it back.
Exactly, yeah. Yep.
So it's a desired behavior. It's just, the reporting tools probably are what need to be fixed, right? Like Top needs to be able to give you an idea of what's used, but what could be reclaimed or something.
Yeah. Right.
I guess as a next step for this could be probably like an RGW workload with a very large database pre-filled. So I imagine that RocksDB is going to have a little bit different behavior with one of these like 20 gig databases.
So if I finish filling it in, I've got the RSS usage is wrong here, so I should just delete this. This is everything except for the RSS memory usage with an RGW workload.
Okay, cool.
And in this case, instead of using like 7.5 gigs or whatever of memory, we've tuned the cache size a little bit lower than it was in RBD. So on RBD, the cache size was closer to like 2.8 gigs. On this one, the cache size was down around like 2.4 instead. And interestingly, that seemed to improve things. Although one thing that's interesting here, right, is that the heap size is growing, and that probably means the RSS memory usage was growing too, even though the map size was not.
Okay.
I wonder if that is RocksDB using more as it gets filled up more.
One thing I was wondering about too is we don't have any information about what like the unmapped segments are. What if it's like a bunch of just tiny like fragmented segments that's giving back?
That's my guess.
What's the kernel going to do with that? So
exactly, yeah.
Yeah, it's not going to want to allocate them for anything. It's going to, maybe as last resort, but.
I wonder if there's a stat on like how many unmapped segments there are, not just how many unmapped pages. Like how fragmented the unmapped space is, that could be factored in.
Yeah. This is maybe an argument to consider JMalloc, right? Because it likes to, my understanding is that it likes to allocate like size stuff in the same runs.
Mm-hmm. All right, well, this sounds super promising. It seems like the next step is just to run some more tests.
Yep.
And then we can draw some more conclusions from that. But I like it.
Yeah, it works surprisingly well already. That's pretty awesome.
Yeah, exactly. Yeah. Exactly.
Right now, I've got like a hard-coded minimum of like, I don't know, 128 megabytes or something ridiculous like that. But we can decide what we want that to be and make it an option. It's not a big deal. Sorry for the cache, the BlueStore cache size.
Okay, so just from going back to the beginning, the one the user-facing question. Should we just make it so that if you set OSD target memory, if you set that option, then the BlueStore cache size is just completely ignored? And then we set we have two new options to go with it: OSD target memory, SSD, and HDD, kind of like we do with BlueStore cache size. And we just set new sort of default memory footprints.
I'd say let's make it consistent for all the other stuff that auto-tunes. Right now, the auto-tuner will take the default ratios and start out at them, but then it will change them. So if we are doing that for those, I think we should do the same thing here. But if we want it to just ignore it completely, then we should have like everything ignored completely and just like start out with, I don't know, some.
I mean, I think the ratio still makes sense within the BlueStore bucket because it's trying to figure out what the starting point is or whatever, how to best use life memory. We don't know that yet. Eventually, maybe those will become obsolete because the cache auto-tuning stuff that you're talking about in the other tangent and whatever would work. But I think and the goal should be that this is the only option that they set, right? And everything else is just using the default ratios or is auto-tuned. And in this case, the main thing that's being traded off is like BlueStore versus like PG logs. And we have options for PG logs, but they're not auto-tuned at all. They're like fixed, and we're not changing that immediately yet. So for now, it doesn't make sense for the BlueStore cache size to do anything. In that case, that's the easiest thing to knob to turn.
So I mean, the only difference, right, is that very, 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 very first data point where that sits, right?
Yeah, I think that's the main thing I would change to make that until we like have reached our full memory usage. I would like have a conservative bound of like only 80% goes to BlueStore. Or you can look at the mempools and like see whether they're fully populated. If the mempools are only at 10% of their configured capacity, then for pglog, then we should also be conservative on cranking up BlueStore because we know we're going to have to claw it back anyway. It doesn't need to be super complicated, probably. I mean, you could get really clever, and you could do something that's probably pretty brain dead and works almost as well.
Yeah, I mean, you could make it like the starting point be like half of the
total
asked for target. Yeah, I mean, whatever. It's not. Yeah, it could just be something like that, I guess, or even like 25% of it, or something that like you said, if you just happen to like fill up the cache before the first iteration, right, in the thread, like it's starting up the mempool thread in BlueStore, and as soon as you enter that while loop, it's gonna like adjust it and change it. But if between the time when that happens, the cache like overshoots, I guess you could end up in a situation where it overfilled.
Yeah.
It'd be really, really unlikely, right? I don't even know.
Yeah.
I don't even know if you could. Can you accept IO before the mempool while loop like runs?
Sure, I think so.
Okay.
Yeah, I mean, just setting it at like 50% of the total seems like a safe thing to do.
Sure.
That's roughly where it is anyway, right? Or steady state in this case, at least. But.
Sure. Okay. Yeah, not a problem. So, okay, we can do that. Trying to think if there's anything else here. I mean, when the PG log gets smaller or bigger, this will, adjust to it. So that's not really a big deal. Yep. They'll work independently of it. It will not, if you set this really low, that's one of the tests I want to do, is to see what happens when you've set the OSD target size to be like
gig or half 500 megs or something.
Yeah, exactly. What does it do in that case? I mean, it should work fine in that it will not be able to restrict it, and you'll get the minimum, whatever the minimum amount of cache you've set is, and then it'll just have more mapped memory than that.
Yep, that sounds fine.
Okay.
Cool.
Well, cool.
Awesome. That's exciting.
Yeah, and it wasn't hard to write this. It took a day.
Yeah.
So
Exactly. Cool. All right.
sounds good.
Anything else for today? All right. Thanks, everyone. Have a good one.
Thanks.
Thanks.
Later, guys.
See you later. Bye.